Something huge may be hiding in our solar system. Not debris, but a full-sized world. For more than a century, astronomers have seen its sign, but never its face. Now, hidden inside decades-old data, something has changed, and for the first time, the hunt for Planet 9 may actually be nearing its end. The outer solar system is nothing like the region we live in. Beyond Neptune, sunlight weakens into a faint glow. Temperatures goes toward absolute zero. Distances become so extreme they defy intuition. At roughly 5.6 billion miles from the Sun, even light takes over 5 hours to arrive. A spacecraft traveling at today's speeds would need thousands of years to get there. And yet, this frozen darkness is not empty.
If you enjoy deep dive science documentaries like this, focused on real data, real mysteries, and the edges of human knowledge, consider subscribing. New videos explore the universe where certainty ends and discovery begins. And let us know in the comments what you think. Thanks for watching.
Spread throughout this region are thousands of icy objects known as trans-Neptunian objects, or TNOs. These are ancient remnants left behind from the solar system's formation. Time capsules from a period when planets are still assembling. For decades, these objects seemed not particularly interesting, small, far than we imagine, and difficult to observe, until astronomers began tracking how they move. The first TNO was discovered by Clyde Tombaugh, Pluto. For 60 years, it was alone. Then, in the 1990s, discoveries accelerated. Today, nearly 5,000 TNOs have been cataloged. What caught scientists' attention wasn't their size or composition, it was their orbits. Many followed paths that made no sense, highly elongated, steeply tilted, some even moved backward relative to the planets, others grouped in the same orientation as if guided by an unseen hand. Random chance couldn't explain this. Computer simulations failed. Known planets weren't strong enough to cause it. Something else had to be there. The mystery sharpened in 2003 with the discovery of Sedna, a dwarf planet smaller than Pluto, but with an orbit so extreme it never came close enough to Neptune to be influenced by it. Sedna's path suggested it had been pulled on purpose by something massive far away. At first, Sedna dismissed as an oddity, but then more objects like it appeared. The pattern became impossible to ignore. To understand why these orbits matter, you have to understand gravity in three-body systems. When two objects orbit each other, their motion is predictable. Add a third body, especially a distant but massive one, and things change dramatically. One well-known effect is the lead-off Kozai mechanism. In this interaction, an object's orbital tilt can be exchanged for extreme eccentricity. Orbits stretch, inclinations spike, stability vanishes. But this mechanism requires three things: the Sun, a small orbiting body, and a distant, dense perturber. In 2016, astronomers Mike Brown and Konstantin Batygin modeled the orbits of 17 unusual TNOs. They tested whether random chance could explain their alignment. The probability came out to 0.00006%. Their simulations instead pointed to a single explanation: a planet-sized object, 5 to 10 times the mass of Earth, orbiting far beyond Neptune, a world on a highly elongated path taking between 10 and 20,000 years to complete one orbit. Planet 9. If real, it would fundamentally change our understanding of the solar system, a major planet, undiscovered, hiding in our own backyard. But there was a problem: no one could see it. Finding Planet 9 using visible light is extraordinarily difficult. A planet that far away reflects almost no sunlight. Brightness drops not with the square of distance, but with the fourth power. Light must travel out, hit the planet, and then return to Earth. At distances beyond 500 astronomical units, reflected light becomes vanishingly faint. Multiple surveys searched anyway. Pan-STARRS, the Dark Energy Survey, the Zwicky Transient Facility, millions of images, years of observations, nothing.
Skepticism grew. Some began calling Planet 9 a mathematical illusion, a ghost created by small sample sizes and biased observations. But the absence of light doesn't mean the absence of heat. Every planet emits infrared radiation, even frozen ones. And that realization changed everything. Instead of looking for reflected sunlight, a team of scientists from Taiwan decided to look for thermal emissions. Led by Professor Tomo Goto and PhD student Terry Fan, the team turned to two far-infrared surveys taken decades apart. The first came from IRIS, the infrared astronomical satellite, launched in 1983. Its detectors were cooled to just 2.5 degrees above absolute zero, allowing it to detect faint heat signatures across the entire sky. The second survey came from Japan's Akari satellite in 2006, with improved resolution and longer wavelength coverage. Together, these datasets contained over 2.4 million infrared sources spanning more than 20 years. At first glance, this made the problem worse. Searching for a single planet among millions of objects is like hunting for a specific grain of sand on a beach. But Fan had a strategy. Planet 9, if it exists, should move very slowly near the farthest point of its orbit. Over 23 years, it would shift position by a predictable amount. Fan calculated exactly how far it should travel across the sky given its expected mass and distance. He then filtered out everything that didn't match. More than 2 million data points collapsed to 13 candidates. Then 13 became 1. In the IRIS image, the object appeared as a cluster of 7 pixels, slightly warmer than the background. In the Akari image, taken 23 years later, it had moved 47.5 arc minutes, roughly the width of 1.5 full moons. Seen individually, the images mean nothing. Seen together, they are extraordinary. This object's movement, brightness, and location align closely with Planet 9 predictions. Its inferred mass falls within the expected range. Its distance places it beyond the reach of previous optical surveys. If confirmed, this would be the first new planet discovered in the solar system since Neptune in 1846. But confirmation is everything. Brown and Batigian have raised concerns. The candidate's orbital inclination may be steeper than expected. The orbit is not yet fully mapped. More data is needed. Fortunately, the perfect tool is finally online. The Vera Rubin Observatory is now operational. Equipped with a 3.2 gigapixel camera, the largest ever built, it will scan the entire visible sky every few nights. Its 10-year legacy survey of space and time will generate 20 terabytes of data every night. This telescope can see objects orders of magnitude dimmer than anything before it. As Mike Brown himself has said, if he were given unlimited funding to build the ideal Planet 9 telescope, it would look exactly like this. Within a few years, the mystery will likely be resolved. Either Planet 9 will be confirmed, or it will be ruled out. And if it's ruled out, the implications are just as profound. Alternative explanations remain. A massive disk of smaller objects known as the Derek-Madigan belt could collectively shape TNO orbits without a single planet. A close stellar flyby in the Sun's early history could have distorted the outer solar system. More exotic ideas include a primordial black hole with planetary mass, invisible unless it feeds. There's even the possibility that gravity itself behaves differently at extreme distances, as suggested by modified Newtonian dynamics. Any of these outcomes would rewrite textbooks. So what's actually out there? A hidden planet? A black hole? Or entirely new physics? Personally, many astronomers hope it's a planet, completing the solar system, restoring the idea of 9 worlds orbiting the Sun. But whatever the answer is, we are closer than ever to finding it. For the first time in 100 years, the hunt for Planet 9 isn't theoretical, it's observational. And soon, the darkness at the edge of the solar system may finally give up its secret. What do you hope we'll find?